Have you ever wondered how satellites are made? The process starts with meticulous design and careful manufacturing. It begins with a clear understanding of the satellite's intended purpose. Whether it's for Earth observation, communication, navigation, or scientific research, engineers and scientists determine the specifications. They consider its size, shape, weight, power requirements, and the all-important payloads it will carry. Just like a puzzle, a satellite is made up of several key components. The structural elements form the satellite's skeleton, providing support for all other components while shielding them from the harsh conditions of space. Then we have the power systems. Satellites usually rely on solar panels that convert sunlight into electricity, but they also have batteries to store excess energy for use during those periods when they're in Earth's shadow. Next, let's talk about the communication systems. These are the antennas that transmit and receive signals to and from Earth. They're like the satellite's voice constantly talking to ground control. Then there are the sensors and instruments. Depending on the satellite's purpose, it might have cameras for taking images, spectrometers for studying light, or radar systems for mapping terrains. And to manage all these functions, we have the onboard computers. These computers control the satellite's operations, collect and process data, and execute commands sent from Earth. Once all the components are ready, they're assembled in clean rooms to prevent contamination. Think of it as a high-tech operating room where the satellite is brought to life, but it doesn't end there. The satellites undergo extensive testing to ensure they can withstand the harsh conditions of space, including vacuum, extreme temperatures, and radiation. They must be resilient, they must be ready, they must be perfect. Because once launched, there's no repairman in space to fix any issues. Once a satellite is meticulously designed, assembled, and tested, it's prepared for the next big step, the launch. And that, my friends, is a spectacle in itself. But let's save that for the next scene, shall we? Satellite launch is a crucial and intricate process involving precise timing and coordination. Once a satellite has been meticulously assembled and tested, the time comes to transport it to the launch site. This journey is undertaken with extreme care. The satellite, a delicate and expensive piece of technology, must arrive in perfect condition, ready to be launched into space. The next step in the satellite's journey is the rocket launch. This process is about more than just raw power. It's about precision. Rockets must provide the necessary thrust to escape Earth's gravity, but they must also guide the satellite accurately into its intended orbit. This requires an extraordinary level of control and coordination. But what is an orbit? Simply put, it's the path that the satellite will follow around the Earth. The type of rocket and its launch trajectory are determined by the satellite's intended orbit. There are different orbits, each with its own advantages for different purposes. Consider the geostationary orbit. This is an orbit in which the satellite appears to stay still in the sky as seen from a point on the Earth. This is incredibly useful for communication satellites because they can provide a constant link to a specific location on Earth. On the other hand, we have polar orbits. These are orbits that pass over the Earth's poles. Satellites in polar orbits can observe the entire Earth as it rotates beneath them, which is perfect for Earth observation satellites collecting weather data or studying environmental changes. The launch process concludes with the satellite's placement into its chosen orbit. This is a critical moment. If the satellite is placed too low, it might re-enter the Earth's atmosphere and burn up. If it's placed too high, it might escape Earth's gravity and be lost in space. The placement needs to be just right. After the successful launch and orbit placement, the satellite is ready to perform its functions. It's ready to start its mission, be it communication, navigation, Earth observation, or scientific research, and that's how satellites are launched. It's a complex, precise ballet of science, technology, and human ingenuity. Once in orbit, the real job of a satellite begins. The rocket's mission isn't quite done just yet, though. It must complete a critical step known as orbital insertion. This multi-stage process is all about precision. It's here that the rocket places the satellite into its intended orbit. A variety of factors, including altitude and orbital parameters, are carefully calculated to ensure the satellite ends up exactly where it needs to be. Once the satellite is in its place, it's time for the onboard systems to wake up and get to work. This is where those solar panels, batteries, and onboard computers we talked about earlier really start to shine. These systems are activated and immediately set about performing their various functions, from powering the satellite to collecting and processing data. But a satellite isn't a lone wolf. It remains in constant communication with ground control stations here on Earth. Using its antenna, the satellite sends and receives signals, enabling it to execute commands from the ground and relay important information back home. Think of it as an ongoing conversation with the satellite and ground station continuously checking in with each other. Now let's talk about the real stars of the show, the sensors and instruments. These tools are the eyes and ears of the satellite, collecting a wealth of data from their vantage point in space. They might be snapping pictures of distant galaxies, measuring atmospheric conditions, or tracking the movements of ships at sea. The possibilities are as varied as the satellites themselves. Once this data is collected, the satellite doesn't keep it to itself. Instead, it transmits the information back to Earth. Here, scientists and researchers pore over the data, using it to predict weather patterns, study climate change, guide navigation, and much more. So, from design to operation, the life of a satellite is a complex yet fascinating journey. From the confines of a clean room to the vast expanse of space, these sophisticated pieces of technology perform a dance that's choreographed down to the smallest detail. And all the while, they're helping us to understand and navigate our world in ways we could never have imagined. So, we've seen the journey of a satellite from its conception to its functioning in space. It all starts with a clear objective leading to the meticulous design and manufacturing process. The satellite's specifications, encompassing its size, shape, weight, power requirements, and the instruments it will carry, are all determined by its intended purpose. After the satellite is constructed and tested in clean rooms, it's then transported to a launch site. The rocket's launch trajectory and the satellite's destined orbit are all predetermined with precision. Once the satellite reaches its intended orbit, it's then time for the real work to begin. The onboard computers, communication systems, and sensors spring into action, collecting and transmitting data back to Earth. Every aspect of a satellite's journey, from design to launch and operations, is a testament to human ingenuity and technological advancement. Next time you use GPS or check the weather forecast, remember the sophisticated technology orbiting Earth that makes it all possible.